Hello, my name is Fluent. We've not coded in C, actually for a couple episodes, which is noticeable, but I'm actually gonna try learning Fortran, because that's what life is about, learning new things. And, I found this, and now I can, download this. Let's go. Yeah, we can put the installer away. The installer is not necessary. Actually, do we have G Fortran? I think we should. Yes. Let's go. Oh, how about that? Huh? How about that? It was so long. Like, I've been spending so much time off stream trying to find out a way. It felt like we had like a main.f90. No, I'm gonna find like way to a syntax highlighter soon. So yeah. So we can just run this. It outputs an A.out. Hello. And we can actually put that all into a file and give it the required access, sorry. And then we could just run. Now let's search for syntax highlighter. Syntax. Fortran syntax. Yeah, why don't we go check this out? Modern Fortran. It's on the top, so it's probably most trusted. And we got that. Boom. And let's paste this code and run it. 36. So it's the same thing as would go here. So we have functions here, and now we might actually do something like this. Fortran tutorial. So some things I don't know still. So we have like that's Fortran is pretty simple. It might replace C as my favorite language. So it's feel like it's obviously new. How about just take that file and we don't need that. So one thing that is a little confusing about Fortran is you have to have like an integer for the variables. So it's sort of like each of these functions are their own compile time. Sort of like that. But that's actually fine. Cause like that's back in my day, that's how you have to do stuff. The hard way. And we could like completely remove that. Actually, and just run. And we get 3. And we could also give it a dimension. So does that mean it's like 10? Like, for example, this would, it won't mean like 2-dimensional. Like, you should know what 2-dimensional is. It's like things like this. 1D is just an array. 2D is like this. But here it's just the amount of elements. Built-in support. Wow. No way. No, would it still allow us to do it because we can't set? Oh, dang, that's pretty cool. So this by default just sets every element to that. Okay. And then we could set it maybe to 5 and say Um, so 2223. Okay, it's like in Python, you'd have like an array, like, and we would do is that how it works, slicing? Python slicing. Or we need an like actual like, and you have to assign in the iteratable. That's why it was mad at me. So we could do 1 to 2 is equal to 4. Even Python doesn't have that good support. What's with this? What? Too easy. Too easy. No. This is too good. This is too good. Fortran. Look. Verb for C. Language. Much better. How? This is too easy. Back in the days, they knew more than we do now. You could also say, couldn't we do like allocate? We could do the size of. Is that a thing? Okay, but we could allocate memory for it, like allocate function in Fortran. There's function like that. Yeah. I don't know why they put all capital and I'm writing all lowercase. So, okay, do you just like give. Okay, that's pretty smart. It already knows what to so we could just give it allocatable. And now it'll automatically allocate everything. And I don't think we can set an allocatable object immediately. Yeah, oh, no mind. Must have a deferred shape or an assumed rank. What the fuck? Oh, I think we can. Wait, just give it that. This is yeah. And then we could allocate. Oh. So what happens if we just automatically allocate some data? So we automatically assign all of its elements. It even has backtracing. The fuck? I need to go to basic 2 plus basic addition class. Okay. So what if we moved this and did it back in that way? You don't need to like allocate data. Similar to C. So why don't we take main data f90 and we say all the elements after the 5th element. I think it works like that, right? Doesn't it? Isn't that how it works? It's a bit it's parentheses. Do you access an element like with the parentheses? Okay, so the other ones, they've not been allocated memory, so they're just random stuff. Yeah. Yeah, that's pretty cool. Crucic I is equal to allocate I. So like allocate memory. Or perhaps give it an allocatable type. Well, allocatable like food shape assumed. Okay, I think we have to like give it a default Oh, rather than doing dimension, we can just directly set it. Let's say 10 elements. So integer allocatable and dynamic arrays. Dynamic arrays. Look at this. See, learned from Fortran. That's all I need to do. What if I deallocate so like I may immediately deallocate everything? Yeah, because I cannot attack get a deallocated object. So I'm gonna automatically deallocate that because I worry about memory, okay? And then also here you could say, could you do like that because it doesn't know the size of the element? Yeah, it doesn't know the size of the element. So maybe we'll just give the first element that. Oh, we need to first before we do anything, we need to allocate the memory for that, and we're just saying it's 10 elements inside of it, and the Fortran knows that those all are integers. And now we could get just first element, and that's just zero. And so here they want to make the whole program allocatable. Do you have to do that? Allocatable. Do you just set it to just allocatable? So end program allocatable. Is that the name of it? Is that actually the name of it? I think that's the name of it. It doesn't matter. It doesn't matter. We also have these. Okay, so similar to what we have in C, back in my C days. And I talk about C a lot. I feel like that probably is annoying. So we could actually give it like len equals 4 first name. And print that out. So first name doesn't have anything assigned to it, so it should just and we could then assign it to Smith or John. So we could do that to like integers. But yeah, obviously. So you can only do it to characters, but still, you automatically have like. Wait, let's see something. Could we like call this ints? And print ints. Len has okay. That doesn't work. It only works for characters. Only special thing for my favorite characters. String concatenation looks like that. C doesn't even have string concatenation. Fortran. My favorite language has changed. So much work the Fortran compiler does. Just so we can sit. This is too easy. All C developers switch to Fortran. Hello, John. John, haha. John, haha. Could you do that with integer allocatables? Could you do that with integer allocatables? Added. And now we'll not do allocatable. We'll just make it 10. We'll give it built-in sizes. And then what if we put it I and merged with added? Would that work? Oh, that's a string concatenation. An entire operator just for string. What? No way. And we could even do something like this. Right, so you could just do like I is equal to 5 4. I thought you had to do like parentheses. Just that, okay. Okay. Ha 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 ha. Dynamic arrays. Fortran is the best. Okay, why don't we create like a new function? Like hello and function hello. We'll just say implicit none. Actually the function some parts of it is complicated, some parts not. Like here it's kind of like why would I need to know that? But at the same time, I like that. It's low level. It's fish to like 5 stars. Ha ha. 5 out of 5. Ultimate rating. And we got 36. Now, okay. I don't like whatever this does. I want it to do maybe square. So we just square it. So let's create the function square. And there you go. We get that squared. And we do a 6. We get 6 squared. We type some random philosophical nonsense. I think this would, yeah. It's too big. Yes. Wait, and we could even give it an operator to tell it to not. What? Main.f90. Holy. Well, yeah, obviously, it still, just ignores that. But still, anyways, let's see the limit. Obviously, that would be too large also. You can literally look at the number. That would be too large because that's squared. Like, you might be like, that squared is like, yeah, it's literally, they literally put the symbol E for that. And, it's not that big because, like, I think, what? Holy moly. Okay, I think, it's negative. So, like, if they're very big, it returns 3969. 3969. Okay, so I think we can't do I because I is the input. I is the input. We specifically said I is the input. Right? So could we like print like over here? We don't even have to like do that because we could just do that, and also we could immediately like set I at runtime. So like this is unclassical. So maybe we could take like integer underscore v. But no v. It must be an intrinsic function. I don't give a shit about all these intrinsic functions. What the? Is that like a subroutine? Definitely not a subroutine. So it's still a lot different from C, but I wouldn't say it's like bad way a lot different from C. So it has to be intrinsic function, not faceted. So could we just okay, maybe you could just do that then. But what if I don't want it to like give us anything? Wait, we just found it. Ha ha. Ha ha. Yeah, that's obviously gonna not end well. Because infinite loop is 3969. We got a favorite number here. 3969. All of the numbers in this multiple a multiple of 3. 3969. And same for this. The unique numbers. If we multiply them, no, we get 15, 752, 961. Okay, I don't know why I'm doing this time. I shouldn't be doing that. Okay. Once this program is done, why don't I deallocate the data that we allocated at the start? So let's deallocate that so we save memory. Oh. Okay, we can't do any. Square is not variable. We need to set to allocatable, so that we can allocate it and deallocate it. Right. But then if we do that, at the start we need some sort of. What? Oh, I think we could just call it allocatable. Please set that. No, I cannot do that. Nah. Because we have to have an allocatable object. It's not just all objects. Okay, so Fortran, my feelings so far is mixed. I like it, but I don't like it. There's some things that are just like. Okay, now I'll just create an allocatable object. And let's just forget about that completely. And we could just print I. It's not allocated. We have to allocate I. So allocate I. And array specification. Oh, we have to give it. Okay. So dynamic arrays aren't that easy. But obviously, like, do you expect it to be easy? Life is hard. Life is so we just perhaps give it like a DA. Okay, that makes sense. Okay, that's actually pretty cool still. So I'm pretty sure it'll give us an error because that's what my code is saying. Link mismatch. Dimension 10. Does the term for dimension change over time? I think it did. I'm not gonna even read stuff. Wait. So back from a little break. And yeah. So we found out that this there's actually a two-dimensional array. Right. Actually, we can go to another terminal. CD Fortran. You can actually use the Vim editor. I just found this out. But yeah, that's one thing I could do, but I'm not gonna do that for. I don't know. Anyways, I'm gonna see um square. Could you print times square? Is that how it works? I think that should work. Yeah. Also, what if this dot main dot f90 dots swp? I don't like it. And I hope we name compile dot back to run dot, cause yeah now I could actually change this a little. Maybe I could set this as real and say real is equal to 5.4. And then here we'd have to initialize that as a real. Yeah, and we got this. I don't know why it's there's that here, but we got it. So one thing I don't get is we always have to do something like that. Okay, what if we would turn an array? So what if this was an array, and all of the elements inside of it is 5 fourths? Then it's real, so you do something like that in order to actually do it. And we can now print that that actually won't work. I get why. It thinks it's accessing the fifth element, right? So we can change the type of this. Now, what I'm thinking of doing is actually creating maybe a transpiler, so that we have random code, and we turn that into a Fortran and run that Fortran. Yeah. So, anyways, I'm actually just create back to that original program. And we can just make it a normal. And then look, gives us 25. I'm thinking, could we do like a random program here? That's so. Oh, look at that. So I can literally name that main F90. I think underscores aren't allowed, yeah. I'll add stars download. And we can literally call it main F90. And it works. And if you look here, it's a ton of philosophical nonsense. Like it usually is. Now we can compile this actually into a main O, which is more concise. And it helps us better see what's inside, like if you're a binary person. And as you can see, the square function is over there. And so maybe something we could do is, what if we took a structure? So a normal structure, right? Fortran structs. That. It's simple. to create a new type, we select type functions and type, and we give it an integer square. Type and type. Well, no work. Okay, that would wait, what? Funk. Oh, I think it might be related to that. Type funk. Is it like based on indentations? Type integer to do hum. The heck? I think we need a separate module for structure. So yeah, we could do that. Like a module, functions and module. Would we have to put like a public? No. Oh, obviously the implicit type. Okay, I'll just actually put this inside of like here, right? Because no, it automatically created that as I was writing it. Forget running. As I was writing that. What the and type. That fixes all of the errors. So I'll just call that square. Or maybe could we just do that here? Yeah, I was using the wrong syntax. Okay. I was not. Then we could like use use is what you use. Functions, what do you say, like test type? So how do so like you obviously have to have an element first of all. So you could say, I think we could use it as a type. Type fruit. For us, type test funk. So type funk. Test. And then we could say okay, let's just ignore that at first. So then we could say maybe like test, because it's test, and run that. Oh, and that. Oh, funk. My bad. We still have one error. Let's see what the heck that is. Oh, so maybe we'll just not specify that. No matter what. Oh, maybe we'll just what if we like tilt it over? Can we use like normal dot? Okay, I think we shouldn't do that. We're just supposed to but could we do like a public variable just called square? No, we cannot. Okay, so implicit none print times square of 5. My question is, do you have to have an input? Could you just like always return like this random number? You could. And we don't even need that line. You could literally just do it like this. Because I is an argument. And then we could have like a standard return. If you don't wanna like do it, you could do like return and yeah, and then we could just return. So return is equals 0. I think if we should call it like let would not like cause syntax errors. And also here we could just do that. Why do we even need functions.mod and main.o? Just simplify this. And yeah, return 0. I was gonna say that's not what we expected. But that's essentially what we expected. And actually we don't like, since we have a ret value built in, which is basically what we're gonna return, we could just simplify the code. And do we even need that return line? We don't need that return line. As you see, just like see, every time you run it, it gets faster. So you can do whatever you want in this. So time ate it out. Look at how fast it is. Look at that. And we can't have public variables, obviously. So we have to be like implemented somewhere. Especially considering that this is basically a program. So maybe we could have all of the functions we create right here. So we have that. Now, what if we did a function? Well, we could like immediately print something in the function, and I think we could do that. That is an infinite loop. What? How does that do an infinite loop? I think it's each of them like no. Could we do like integer res? Res is equal to no implicit type. Yeah, that actually works. And then we could like print that over here. Yeah. And we could do something as simple. So we can't. One thing we can't do is just ignore it. We can't do that. Which is pretty stupid, but it's stuff. And we could like name this underscore underscore. Oh, v underscore underscore one. And that's just like a random unnecessary variable. And actually, we might as well we have our allocation, so we might call it allocatable. We can obviously allocate the memory. And at the end of the program, since we don't need it, we can deallocate the memory. What happens if we deallocate it immediately after? It would have no memory, so I think it would be given error. No, so we don't even. Okay, so what if we just had an empty variable? Like, I guess it's 0 bytes. No way. The actually is not given error. So we just. And we can make this anything you want. Like, we could make this real. And that wouldn't work. Yeah. Actually, yes, it does. Some places it does work, some places it does. And here, look at that. 25. Oh, so that's the magic of this. You can it implicitly casts. Could you even do like an integer cast? That's not allowed. So rather than doing like casts here and there, my guess is because Fortran has so little data types, it's very easy. Look, I'll literally give you that. Look at that. It's also a complex type. Actually, one thing we could do is if this is an array, technically it is. And so actually it's not, but like, yeah, none of these are arrays. But let's see, we actually pass in array. Are we allowed to like immediately? Yeah, we're allowed to immediately initialize them. And look, that's the actual size of the array. So that's the actual size of the array. We're able to do that. Now, we could do like a logical type. Like, how would we do Boolean in Fortran? Yeah, there's no. My guess is you just use an integer. I guess it is. So like think of a like type. Like what should we call it? Oh, bool. Right, and we can end that type. That creates errors for the rest of this thing. So maybe we could create like a magical hello and end. And it creates that. It's actually called bool. Oh, we can't have bool, yeah. So we would say Boolean. The bool. Bool. Okay, now we have a ton of files. Bool.mod, bools.mod, hello.mod. There you go. All of them are removed. Now we have that. And we could use bools. And essentially what that is it's an integer bool. That's literally all it is. A simple integer. It can be either 1 or 0. And we can actually use that. Now, bool. I think we have to do like type bool. And here, could we just do that publicly? We cannot do that publicly. Type bool. Now it should suck. Except for here. Well, they're basically the same thing. Don't you think? Don't you think they're the same thing? Don't you think you're the same? They're the same thing. I think the clear difference is that they're clearly different things. Because you can't like directly cast. Because although it does contain it, you can't like cast like that. So we could say like something like that, and then like I think we could say percentage bool. I would rather implicit none. Would use bools. That should fix all those. Except for this one. Yeah, they're different things. So I could actually switch that over to bool. That actually fixes everything. No way. That actually, okay. There's one error. Implicit none. So you statement can't have implicit. So I think, wait. Do you like initialize it? Yeah, that fixes everything. That fixes everything. So we have our own module called Boolean. Bools. And it handles Booleans. Now actually another thing is like preprocessor in Fortran. Does Fortran have a They have I think they have a preprocessor. No. So we could also like define like false 0 to 1. I thought that worked. Oh, so you have to do that. So you have to do like a special macro just for supporting that. Actually, what we could do is we could actually create an integer called false, and false is 0, and then true is 1. So then now, what we could do is, well, this is not the correct place to use booleans. I'd rather not use booleans all over here. That would just make the whole world a mess. So I'd rather make these integers. Integer. But still, nevertheless, we are allowed to create a boolean b. That's true. So let's just do 1. Because I hope that worked. That's not, I think we have to do like, yep, b is equal to 2. And let's just print b. Let's just see what the errors are. Type bool b. Do 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 do. Da 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 da. I'll just set it to 1 and see if that fixes everything. It doesn't. Type bool b. Type. Could we actually treat it like that? No, we cannot. Type bool. Colon. So we have to use type. I would say BW. Why not BW? It still gives us errors. Unexpected data What? Did that fix anything? Maybe we'll move it up there. And that too. And that makes it even worse. So, Boolean. Do we need Boolean does not exist. Simple Boolean has no implicit. When did I care for the implicit? Oh, such an idiot. What? Maybe I'm not an idiot. Well, maybe I'm an idiot, but not an idiot as an idiot. Yeah. Maybe I'm not as much an idiot. That's out of it. Yeah. Haha. What's wrong with doing that? Integer. What is the problem with integer? That works. It means its type. That actually work. Now we're saying. Now we could actually set it into a Boolean. And now set the inner bool inside of it. Now what if we put like after that we said we create a Boolean and we create two Booleans. So this is like bool 1. False is 0. So now I could say B is equal to false. Okay, so we actually have stuff that works. Actually, let me make it more clear. I made like a cover in parentheses. Yeah, and we have parentheses here. So they don't look the best, but maybe we could actually set this to could we do private? Okay, that would actually work. Now I can't represent it. But it does actually set everything private, so that's pretty smart. Pretty cool. But the problem is now when we need to get inside of it, it won't work. So I've learned a lot about Fortran. Like we could do like Fortran struct functions. Do they allow functions? Or we could do a function pointer. Yeah, we could do a function pointer. So we could do like an integer bool function. And the next part where we could actually put this as a function. Well, what happens here is that it needs that. So for now, I'll just assign those two as 0. And then we would add a function. Functions are not allowed here. Okay, so it would be very easy implementing stuff inside of Fortran actually. So just create like a library full of stuff that would be useful. Right. So and since Fortran is heavily mind-blowingly similar, we could actually create like a utils. Utils.f90. And we could say here, program utils and program utils. And could we actually run utils? We can. Would you look at that? Then we could turn utils into a utils.o. Now we can compile against utils.o. So now oh, it's not like predefined. We need to do something what if we just pretended is there like an equivalent type def? What the? So type def in Fortran. Wait, that actually exists in Fortran. No, it doesn't. I'm back, actually. What if we use rules mod? Could we like link against it? Wait. Something like this. No. At one time it won't understand. So maybe I'll just put that in. There's some things that I should so let's say error. Okay, oh, I need to put so like there is no program. Actually, if we're compiling, we don't need to worry about that. We also need to resolve it. So we need to do that. That is equal to 0. Text. We'll just print the text. Okay. So we'll call it rather than program, we'll call it module rules and module. Let's remove all that, and then what if we do it? Look like an integer error. there with the fact that I keep on having to go over and over again. So now, if we compile against the utils, so let's just say that the air is always hollow. Hollow, man, frunde. Where do we get that shot? Why does it always do that? Okay. Do. Make sure it has no arguments. So it has no arguments. Line. And used dummy. That's a very bad word. Haha. Dummy. Oh, the problem is with the text. It loses its type. Hmm. That's what it says. Hmm. Color designate. Hmm. Would you look at that? That's all we needed to do. And now, let's see how to change the color. It's actually like a built-in I know there's inside escape codes. Let's just check that out. No. And we need to compile using a special assume BSCC. Hey, what? Hey, what? I'm seeing end cases in Fortran. Would you look at that? Would that actually work? No, obviously. Well, yeah. I don't want to get any external dependencies. So like Unix X codes in Fortran. I thought it was inside. I want to use like the built-in ANSI code instead. What? Wait. This actually gives it an maybe I could even do like a to-do. Like your phone to-do was thrown. You have marked this object to-do. I will not help you, but you to find it. Peace out. Yeah, a very annoying way to do. Yeah. Okay, it's not long enough. Mark this object to do. I will not help you, but you are to find it. Peace out. There you go. Is that pretty cool? Maybe I'll put like a yeah. I could also do an oopsies. Yeah, but the arrows are not like long enough. So maybe I'll make it like 20 characters long. Oopsies. What is this one character thing? I don't know. I could actually like assign it like this, could we? And then like then put the length right over here. That completely broke everything. Let's do something like that. And we can't switch it around. We have to do sorry. And then we could actually do that. Okay, wait, that's what? So we could put in that character. But what is it? So let's go and see. I think it's 0. Isn't a character 0? At least I think so. What? You tell that it's giving random extra information. Okay, now do I have to go here? But I just saying the name of the file. No, it's fine. Anyways. That's pretty cool. Is that pretty cool? Carbon. Okay, well, I'm just messed up in this. Okay, these completely different. Okay, I'm asking. I don't know why I went there. But how does this exist? You can actually do that. Illegal. Let's remove that and then run it. Still doesn't. Okay, I don't know if it's legal or not. Awaken your inner CPP. Fortran, awaken your inner CPP. And we'll actually remove that from there. Like, well, we could do that here. I'm gonna actually need to. Yes! It does the same thing. We can say utils1. What is utils? What? The fuck? It's 1. Okay, whatever. Maybe we'll give like a forward declaration. Like, what I mean by that is like, put that in. So it's for. Okay, whatever the heck. I guess these defined stuff. This is defined stuff doesn't really. Does it? We did this. Maybe we could do like a. Okay, so there's a lot of stuff to do. Wait, how do you do light function? Light in Fortran. I want to wait to SEO. Does that exist? I think 7. Cutting all this 7 is SEO. You know what? Maybe. Why don't we go back to the days? Hello. And get a program that actually runs. Okay. So what did we do? So let's actually test my ability. So what's the result let secret return where what is equal to 0. That we're gonna do that. I maybe print it out. I don't know, see what that is. I'm gonna say integer W, integer stuff. W is equal to stuff 5. There you go. Haha. I created that. And maybe what I could do next is like create a transpile. Do the transpile. So to compile, let's say you know, some code like program. Maybe this is how it could look like. So main, we would like put all of this side of a main. And functions are declared like that too. So like hello. No, we'll just call this program. So the main, so the entry point is called program. And now if you have like a function like stuff, you have to give it an argument. That and then you could actually do RG and RV in Fortran. Is that built in? So could we by default say like print times get arg? No. Actually, what would happen if we so next we can do that. We've not experimented loops, so it's still a lot more. Um, would you look at that? So now I'd rather like a better like please. Oh, you told me the whole time. I could have just used your call function. Do not use life lesson. No, I would rather like everything like this. It's my way. My way. Everybody has their own way of doing stuff. So like, okay, so we have I is equal to 1. Okay, and that's a I. And okay, so get out does exist. Then why the heck would it not let me? Oh, I think I used the wrong arguments. Maybe. So I. Okay, so what did we learn? What's the moral of the story? Fortran is the best. Seed bubbles upgrade to Fortran. Updated for right now. When I heard NASA uses Fortran, I thought of it as some frail language. I was like, why does NASA use this? But NASA should be using this right now. But not NASA, it was someone else. I think NASA uses XC or something. What would you look at that? Maybe we can make the length up shorter. So basic string. We can use get out XC. Okay, that's pretty smooth. So we might actually like have like that. I mean that so that's like I don't know how to create a file of them. We can like cd example and let's say like add up. Let's just but call it an S. Okay, why all of these names occupied? I've used S before, so I shouldn't have. SB. Finally. I don't know what I'm saying. So we could create something like maybe main. And we could like do something instead of the main function, like print hello. And then the functions could be like stuff AI. And then anytime you want you can okay, I'm back. And you would call something like this. So essentially, I'm thinking of this as a syntax. So we have a rules module. That does all the rules stuff. Okay, that's pretty cool. Okay, I'm back. And so if this actually gets we see something like why wild doesn't exist. Yeah, we'll just do the middle of that. So what are loops in Fortran? So just do loops. It does just do loops. Actually, what I'm thinking about doing is what if we moved either one of these libraries like string.rc or something, or in out.c, or maybe even the LaughX library because it has this. We could port it over to Fortran. We actually could. The only thing we need to do is create a Fortran equivalent of all of this stuff. This is gonna take a lot of work. So not implement that yet. Maybe like create like a maybe like a function that could get an argument. Right. So essentially we could create a function that rather than doing something like get arg, we could create like our own version like get arg, and that only takes to I, and you do something like this. Like that's what I think we could do. So let's go to utils. Let's create like a function called agree. Get agree. And I'll just get the result, and then here we can end that function. Okay, now it's fixed. And then we could create like a string. Now we call get arg. We take the I here. Do something like that. I think that would work. So we could like get arg v and print that out. No, in Dutch. How about we say hello? Could we like pretend this is an int? Did you? Okay, so the function is around, the problem is around here. We actually take an integer I, and we can then use that I. What the heck is the problem with that? just call that. So can we return strings? You don't need a result. Maybe we could bring that intent in. So we know it actually gets that. But now what if we print the return value? Congrats, we are able to actually detect. Let's directly print times. What? I mean, if you could do that, could we like directly print? No, you can't directly print it. Maybe a new one, if that's possible. It's I. What? So it's not able to print. Actually, we don't need a utils function. We just call and then get out cookies unnecessary. Yeah. And we could actually set it off at 0. There's still actually a way to figure out. I don't want any thing. It's write text without new line in Fortran. So I don't want a new line. Advance is equal to no. Okay, that's pretty cool. So no advancing. Oh, you could just put the arguments directly there. What? Intact is odd. So does times mean a CDO? So this would work. So I may as well just put what the heck does that do? We have to put no. So that would actually be good. Wait, what? Oh, it needs a parentheses. Parentheses. Okay. So then, just like that. Oh, that's string concatenation operator. Then we gotta add R between these two. There we go. Fortran is not case sensitive, so that would work. Maybe I could even put like a comma after each of them. There's this much space. But anyways, we would obviously anytime switch it, the advanced mode to yes. And we have that. So, so what should we do now? Maybe we should add some more utils. Wait, so like, could you do like a, no, you don't have to have a let. So this is how a void function would look like. So could we have like a generic pointer in Fortran? Generic is like, if you don't know what it is, it's void times, which means pretty much anything can be inside of here. We could even use void pointers. And transfer. So basically like C casting. So casting data T. So let's just rather than saying generic, is like void times. That's interesting. Character is an unsigned character. you have a logical. I feel like logical is the implementation of Boolean. Boolean's only here. It might even be ternary. Merge. Okay. So it's a ternary operator. And we could test that. Oh, look at this. It's similar. Okay. IW. And last we'll print whatever is in there. 5. Okay, let me check this statement. 5 is greater. Yeah. And then if we put it around, we would have the exact opposite value. String. So, Fortran has a merge operator. And I think it might have the define preprocessor. So, preprocessor in Fortran. Wow! Would you look at that? Can even check whatever the heck this is. Why don't we check that out? I think we still need to compile with the flag. Wait. Yeah, we obviously need to compile it with. There was a flag. -cbp, that was a flag. Okay. So now if we want it, compile it with -cbp. So okay. But I think there is still a preprocessor. Is there a preprocessor? We can go to Fortran --help. There was a preprocessor. Why don't we pre-process this simple code? It's as simple as we got. Which is good. So then we could go utils. That's a little longer. The preprocessor doesn't do a lot of it necessarily. In this case, Fortran. Wait, we could just say no CBP, and there we go. No CBP. Yeah. Still doesn't work, obviously. Myth busted. Yeah. What the heck is that? Why is the heck is tabs like unnecessary? I thought Fortran was a tab and untab Fen replays, but it's not. And terminated else. What the fuck does that mean? What? Print haha. Oh yeah, I forgot. We can't do that. We can't do that. We can't do that. Don't do that. 20 times haha. Oh, we have to do end if. I'm stupid. 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 No, actually. Wait, in graphics.h. Yeah. I'm Target OS Mac. That's actually who I am. Print times ho ho. Mac OS. And let's call this Apple. Okay, so it's not there by default. What if I force it in? There we go. We can force it in. Because Fortran doesn't support that. Okay. Anyways, I think that's it for the video. I'll see you in the next one. Goodbye.